In this topic, you will be seeing the nuclear power plants and its overall usage. We will be starting with the basics of the nuclear engineering, followed by layouts and subsystems of nuclear power plants, along with the working of the nuclear reactor, under which we will be seeing the boiling water reactor, as well as pressurized water reactor, followed by the Candu reactor. So these three reactors are the basic kind of the reactors, and in that specifically the Candu reactor is commonly used in Canada for the specific purposes, and followed by we have the very latest reactor, that is breeder type of reactor, fast breeder reactor, which in which the reactor uses the same it will convert the fissile material into the material which can be used in the reactors, followed by the gas cooled reactors, and along with that we will be seeing the liquid metal cooled reactor, and finally we will be dealing about the safety measures or the safety protocols that has to be followed for the nuclear power plant. So under the basics of the nuclear engineering, we have to know what is the need for the coal nuclear based power plant. As we see here, the coal based power plant is typically 23%, and from the oil we will be getting around 41% of the power, and from the natural gas we are supplementing the power usage to 22%. And where we are lying is that the nuclear power plant we will be using around 80% of the power needs has been satisfied with the help of the nuclear power plants. As you can see the comparison, the majority of the power produced is from the coal based power plant, so which is a pollution based power plant, right? So in that aspect we have to reduce the pollution, as well as we have to reduce the dependency for the non-renewable source of power. So you can see the electricity production from the coal, it is 52%, where the major contribution or the major shareholder for the power production is from the coal, and nuclear we have somewhere around 19%. From gas and gas we are compensating the power to 15%. And coming on to the basic of the nuclear engineering, what you have to know from the basic normal basic structure is, in the atomic structure an element is defined as a substance which can be decomposed into other substances. If you take an atom, this atom is typically on its full form it can be called as an element. So element is defined as a substance which cannot be decomposed into other substances. The smallest particle of the element takes part in the chemical reaction is called atom. So we can take the whole component as the element, and in that whole component we have the very minute component, or we are taking a very small segregation that can be taken as the atom. The chemical composition consists of the union fixed number of atoms in one element with the small fixed number of the other elements. So as you can see here, we have the nucleus, in which the Z is the atomic number and A gives the mass number. So mass number and the atomic number contribution has been given. So we have the nucleus as its central core, followed by the outer boundary layers of the electron. So we name the electron as a shell. So in an atom, the integral central part can be called as the nucleus, the outer part can be called as the electron. So you can see for the hydrogen, the mass number is 1 and the atomic number is 1. And for the helium, the mass number is 2, the atomic number is 4. So it's keep on increasing like that. For lithium and carbon, we have the increase in the mass number and the atomic number based upon the number of electrons that is available in the atom. So as you can see here, the atomic number and the mass number. What is the representation for the atomic number? So the number of protons present at the nucleus can be called as the atomic number. It is denoted by capital Z. So the total number of nucleons in the nucleus can be called as the mass number. So in the previous slide, as you can see here, the atomic number has the common representation of capital Z, and the mass number has the representation of A. So wherever the Z is being denoted, it can be taken as the atomic number. Wherever you can find the capital A, that has to be abbreviated as the mass number. Yeah. So what is the difference between the mass number and the atomic number? Gives the number of neutrons present in the nucleus of the electron. So wherever you want to find out the number of neutrons, so this number of neutrons calculation is much needed for the reaction to take place in the given component. So this number of neutrons is nothing but the difference between the mass number to the atomic number. So isotopes, when you talk about the nuclear engineering, the common and the most important parameter is the isotopes. So some elements exist in different forms. So if we take hydrogen or helium, it can be available in different forms based upon the number of atoms present in, or based upon the number of nucleons present in it. So some elements exist in different forms. The mass number of these components is different from the atomic number. So whenever there is a change, there is a possibility of difference between the atomic number and the mass number, it can be called as the isotope. So this atomic mass unit is a very important thing that has to be taken for the consideration of the power that is being exposed with the help of the particular given atom, right? So the mass of the atom is expressed in terms of the mass of the electron. The atomic mass unit is generally given in terms of the unit of 1.66 into 10 power minus 27 kg. Nuclear binding energy. So when you talk about the nuclear binding energy, it is very much similar to the atomic mass unit. It is one among the parameter in which the choosage of the material or the choice of the reaction material has to be taken. So the energy released at the moment of the combustion of two nucleons to form the nucleus of the atom can be called as the binding energy. So this binding energy is nothing but the energy which has been released during the course of interaction between two nucleons. As we have already seen, the nucleons is nothing but the difference between the mass number to the atomic number. So if you take the total mass number and you are dividing, or you are reducing the total numbers with the help of the mass number, then it can be called as a nucleons. So the total number of nucleons is the representation between number of that is mass number minus atomic number. So the nuclear energy released is generally represented by the electron volt, it is EV. So 1 electron volt is 1.602 into 10 power minus 9 Newton meter. So in other words, it can be simply noted as joule. So 1.602 into 10 power minus 9 joule. Radioactivity. So when you take the nuclear material into consideration, the first thing or the first hindrance should be taken from the parameter called the radioactivity. So this radioactivity is the phenomenon of the spontaneous emission of the powerful radiations exhibited by the heavy elements. The elements of the highest atomic number such as thorium, radium, polonium, ionium, actinium and uranium consist of unstable isotopes. So starting with the radioactive dating, so which is the common nowadays it's very common to take the dating of that particular component. So radioactive dating is somewhere dealing with the carbon dating, the method from the carbon dating. To study the radioactive decay, carbon dating has been used. So what does this say? So carbon 14 is a radioactive isotope of carbon formed by the action of the cosmic rays on the nitrogen of the atmosphere. So what are the basic nuclear fluids that can be used for the power plant is nothing but the metals such as uranium, thorium, plutonium can be used to produce the nuclear energy. And the most common thing is if we take the fuel into consideration, the first classification will be from the fissile fuels and the next classification from the fertile fuels. So if we take a fuels on a whole, it can be classified into fissile and fertile. So the fissile fuel is nothing but you have to simply understand that it is a non-unprocessed fuel. So it cannot be directly used in the power plants. It has to be processed, and the fissile has to be converted to fertile. Then we can use it in the power plant. So it is a raw material. It can be taken as a raw fuel. It can be called as a fissile fuel. Whenever the processed fuel has been taken, it can be taken as the fertile fuel. As you can see here, we have the uranium 92-238. This gives the presence of atomic number as well as the mass number in that particular element. So what are the necessary properties? The necessary properties for any nuclear fuel is that it has to undergo the fission process. So we have basically the two processes, fission and fusion. So the fission process is nothing but we have to disintegrate the single larger nuclei into different forms or small particles that can be called as a fission process. So the necessary properties, under the necessary properties, the material which is chosen as a uranium that is chosen as the fuel should have the higher tensile strength to prevent the buckling of the fuel element. And basically it should have a high radiation stability to resist nuclear radiation against buckling. And the final thing and the most important parameters for the fuel is that it should have a better corrosion resistance and machinability. As you know, when you fill the cylinders with the pellets, small pellets, we have to make sure that the uranium has to be filled inside the cylinder. So this filling of the uranium fuels is done only with the help of the proper machining inside the particular cylinder. So the slots has to be in such a way that the cylinder has to be filled with the pellets without any smaller gaps. And very basic identification that has to be done or to be checked is the ductility of that particular component. So the fuel, whatever fuel you are choosing, that should have a better corrosion resistance, machinability, along with the higher ductility. Coming on to the mass defect, the mass defect, as we have seen in the atomic mass unit, it is one among the parameters for choosing the fuels. So what is the mass defect of the nuclei? When two or more particles interact to combine to become a larger particle, then the total mass of the system will decrease to the lesser number of the smaller sum of the mass of the individual particles. So if we take component A and component B, when you sum up the particles, basically what you have to understand is that when you are summing up the particles, the entire mass of the component would be increased. But as in the case of the mass defect, when you combine two or more components, the original mass of the component will be reduced from the sum of the components. Clear? So if we take 10 as the total sum of the components, that 10 will not be formed during the course of the mass defect, during the formulation of the mass defect. What you have to understand is the 10 will not be the final thing that has been arrived for the mass defect of the nuclei. The stronger the interaction becomes, more will be the mass decrease. So when we have the smaller, when we have a very strong interaction between the particles, obviously we will be having the mass decrease, right? This decrease of the masses can be called as the mass defect. So whenever there is an interaction, as you can see in the case of the nuclear fusion process, whenever two components interact together, we will have a larger energy that is being exhibited from the component. So in this case, that is a very logical thing. And in the case of the mass defect, when two or more components are joined together, obviously the mass of the total system, the total element will be reduced. So the mass of the element will be reduced during the course of the interaction. So that value has to be taken for the consideration of a nuclear fuel. So this particular parameter can be called as the mass defect. So half-life is a very important characteristic of a nuclear fuel. The radioactive half-life for a given radioactive isotope is that it is a measure of tendency of the nucleus to decay or disintegrate, and it is purely based on the probability. So the half-life period has to be calculated based upon the decay period or the disintegration of the atomic particles. So what is AE? A is the amount of substance left, A naught is the original amount of substance, and T is the elapsed time. And you can see here, as we can see here, this is a very basic nuclear power plant. So we have a nuclear reactor, and we have a heat exchanger in the central part, and we have the accessories, that is the components which converts the heat energy into electricity. So what are they? Turbine, condenser, feed pump, followed by the heat exchanger. So these systems will ensure that the proper conversion of heat energy into power or the electricity is being taking place. So the layout and the subsystems of the nuclear power plants, we are starting with the main components, that is nuclear reactor, heat exchanger, steam turbine, condenser, and electric generator. So in the nuclear power plants, the reactor function is very similar to the furnace of the steam power plant. So it contains the pressure vessel, fuel rods, moderator, and shielding. So basically, whatever nuclear power plant you take, you have the pressure vessel, rods, moderator, and shielding. What are the main components? The various components of the nuclear reactor will be having the nuclear reactor core. Reactor core, the main purpose of the reactor core is that the entire course of the nuclear reaction will be taking place inside the core, and followed by the moderator. The function of the moderator is to stabilize the chain reaction that is taking place in the nuclear reactor. The main function is to stabilize the nuclear reaction rate inside the reactor, followed by the control rods. So this control rods will, the basic function of the control rod is to initiate or to stop the course of a nuclear reaction in the inside the nuclear power plant, and reflector is to simply reflect back the neutrons in that particular process, right? So then the neutrons, the electrons, the neutrons should not be escaped from that particular shielding, so that has to be ensured with the help of the reflector. So we have to choose the reflector in such a way that no neutron should be escaped from the inner core of the power plant, and we have the cooling system to reduce the internal core temperature of the power plant, and we have the reactor vessel to withstand the entire pressure and temperature of during the course of the reaction, and we have the biological shielding. Basically, the main safety protocol that has to be followed is that if some amount of radiation has been taken out from the nuclear power plant or escaped from the nuclear power plant, it will cause the hazardous effect to the people. So we have to have the proper biological shielding in the nuclear power plant. So this is a reactor core. As you can see here, the reactor core is the outermost boundary is the reactor vessel, and the inner part consists of the center core, and the core which consists of the core is nothing but it is a summing up of the control rods along with the reflector, and we have the moderator and fuel rods. So this four integral components will be cumulatively taken as the nuclear reactor core. So whenever we talk about the core is the combination of reflector, moderator, fuel rods and control rods. The fuel elements are made up of the plated or rods of uranium metal. The plates are usually cladded with the thin sheet of stainless steel, zirconium or aluminum to provide the corrosion resistance. As we have already discussed, the element should have the proper corrosion resistance, and the machinability rate of that particular component should be much higher. The fuel is shaped and located in such a way that the heat produced with the reactor is in the uniform way. So as you can see here, it consists of the nuclear fuel. The the reactor core consists of the nuclear fuel, the neutron moderator, and the space for the coolant. The nuclear fuel is an element or an isotope whose nucleus undergoes nuclear fission by the nuclear bombardment, and it's produced a fissionable chain reaction. So adequate arrangement has to be made for the fuel supply as well as charging or discharging and the storing of the fuel. So what is the purpose of the moderator? The process of the moderator is to slow down the nuclear reaction that is taking place in the nuclear power plant. So the method of reducing the speed of the reaction is done only with the help of absorbing the neutrons from the particular thing. So whenever you observe certain amount of neutrons, obviously the speed of the process that is taking place inside the reactor will be reduced. So this neutron plays a vital role in order to kickstart the process or to slow down the process or to stop the process. So for all this process to happen, we have to either supply the free neutrons into the reactor or to absorb the neutrons from the reactor. So the moderator is a material which is used to slow down the neutrons from the high velocity without capturing them. So what is the function of the moderator? So the moderator will moderate the process that is happening in the nuclear reactor. Moderator function is to slow down the process of the reaction. As we have discussed earlier, the moderator will slow down the process of the reaction. So what are the basic moderators that can be used is that we can use either heavy water or we can use the normal water, beryllium, graphite, helium gas, right? The last one is the helium gas. So the helium gas are the commonly used moderators. So based upon the kind of reactors we are going to choose, we have to select the suitable moderator for the particular nuclear reactor. What are the moderator properties? It should have high thermal conductivity, high slowing down power, low parasite captures, it should be lighter in weight, and it should be highly stable. The function of the control rod is to shut down or to kickstart the process of the reaction in the nuclear reactor. The cooling system has to carry out the particular amount of heat that is produced inside the reactor. The cooling system should have low melting point, low boiling point, and low viscosity. So biological shielding, as we have already discussed, it should be able to absorb alpha, beta, and gamma type kind of radiation that has been effectively taken from the nuclear reactor, and the shielding material should be of the uniform density, and it should not be decomposed by radiation. It should be fire resistant as well. So basic kind of reactors that we can see is the boiling water reactor and the pressurized water reactor. In the boiling water reactor, you can see the reactor core followed by the steam turbine, condenser, and heat pump. So the boiling water reactor will be using the normal water as a moderator, as well as it can be used for the purpose to control the chain of process of the nuclear reaction. And in the case of the PWR, that is pressurized water reactor, we have the pressurizer that has been used in the pot. As you can see here, we have a additional component. This is the pressure equalizer. So this pressure equalizer will ensure that the reactor is working based in the higher pressure value. So whenever the pressure is being increased, it has to make sure that the coolant, the reactor is running at a particular required pressure. So we have a critical pressure value in which the reactor should be operating for the entire course of the operation. It should be operating in that particular pressure value in order to maintain the production of the power, as well as for the other output characteristics, other improvised output characteristics. So that's all for today's presentation. Thank you, and we can see this in the other classes to come. Thank you.